Hi, my name is Mr. Chu and I welcome you to my study room. If this is your first time, then I want to encourage you to subscribe to this channel for more videos. Today's study is going to be on the gradient or slope of a straight line. The gradient or slope of a straight line is the measure of the steepness of the line, and it is usually represented with the variable m. So the gradient of a straight line can be determined when 2 points on the line are given. It can also be determined when any linear relation or equation is given, or from any linear relation or equation. It can also be determined from a linear graph. And the last but not the least, by which it can be determined also, is when given the angle the line makes with a positive x-axis in the Cartesian plane. So when given the angle of slope. Let's take the very first way by which we can find the slope of a line. So finding the slope of a line when given 2 points on the line. Assuming we have two arbitrary points with coordinates, or being A with coordinate x1, y1, and the second one B with coordinate x2, y2, then the gradient or slope of the line joining A and B, which we say we can call M, will be the difference in y values over the difference in x values. Difference in y values over the difference in x values. And difference in y value simply means y2 minus y1 all over x2 minus x1. And this can also be written as y1 minus y2 all over x1 minus x2. You just have to make sure if you bring y1 first, you bring x1 2 first. If you bring y2 first, you bring x2 2 first. Let's take some examples on this quickly. So we have a general instruction that says that find the gradient of the line joining the following points. And the very first set of or pair of points are A has the coordinate 2, 4, and B has the coordinate 5, 6. So using our formula, we have to quote that M equals y2 minus y1 all over x2 minus x1. And like I always like to do, let me label them x1, y1, x2, y2. So our y2 is 6 minus y1 is 4 all over x2 is 5 minus x1 is 2. And this is going to be 6 minus 4 is 2 and 5 minus 2 is 3. It means the gradient of the line joining these points, these 2 points, is 2 over 3 or 2/3 is the gradient or slope of the line joining the 2 points. We take a second example, which I would like you to pause the video and work it quickly. Yeah, so our second example is you should find the gradient of the line joining the point A with coordinate -3, 6 and B with coordinate 7, 11. I want you to pause the video and work it. And if you work it well, your answer should be 1/2. If you don't have that, you can pause it and then look through again. We take another example. Question 2 says that the gradient of a line passing through the points E with coordinate 6, 7 and F with coordinate x, 8 is 1/3. Find the value of x. So this question is a little bit different from the first two that we solved. In the case that here we've been given the gradient or slope already, and then one of the coordinates of one of the points or the x coordinate of the second point is missing, which you have to find. We are going to use the same formula by substituting the values in and making x the subject. So that will just make me to quickly quote the formula, then we can fix our values in. So we will write quickly that our m equals y2 minus y1 all over x2 minus x1. Again, just not to make mistake, this is our x1, this is our y1, our x2, y2. All right. So we've been given the gradient, that is 1/3. We have to replace the m with that. And then our y2 is 8 minus y1, 7, x2, x minus x1, which is 6. Then when we cross multiply, we are going to have x minus 6 minus 6 over b equal to 3 times 8 minus 7 is 1. So we having x minus 6 being equal to 3. Now x will be equal to 3 plus 6, which will be equal to 9. What this means for us is that the point E and F will have the gradient 1/3 when s component of the second point is 9. We take the very second condition of finding the gradient or slope of a line. That is when we are given any linear relation. How do we find the slope of that line? So the equation of a straight line is ax plus by plus c equal to 0. And also by this one we can make y the subject to get y equals mx plus c. So when we are given this, let me talk about the right hand side first. When we have the equation of a straight line in the intercept form this way, then the coefficient of x becomes our gradient. And the c here becomes the y-intercept. And the y-intercept simply means when you draw this line or when you plot this line in the Cartesian plane, where the line will cut the y-axis becomes the y-intercept. All right. So that is what happens if the equation is in this form. And in this form, like I said, it's just a matter of making y the subject of this. And any other thing, it can be a fraction, being the coefficient of x, but we just decided to make it only one variable. That's why we replace everything by m. But then in case making y the subject becomes difficult for you, then you can use this one straight. You get the gradient as being negative a over b. That becomes our gradient. So in this case, you see that when you make y the subject of this, you are going to get negative a over bx. So the negative a over b is what you are representing with one variable here to be called m. So that is just the same thing. So instead of making y the subject, you can just use this formula, m equal to negative a over b, and you still get your gradients. We take an example on that quickly. Our general instruction is for each of the following lines, find the gradients and intercepts on the x and y axis. All right, and our first line is 7x plus 4y plus 2 equals 0. So with what we have done now, we can see that the line is in this form. It's in this form and not this form. But like I said earlier, you can change it to this form on your own by making y the subject. You are going to get the same thing. So from here, if you are using this, then we can say that the gradient is negative 7 over 4, because our a is 7 and our b is 4. And since the equation is in this form, I'm going to talk about another way by which we can find the x-intercept. So like I said earlier, the x-intercept is where the graph cuts the x-axis, or your line cut the x-axis, and the y-intercept is where your line cut the y-axis. And whenever you draw the Cartesian plane, you see that the x-axis passes through 0 on the y-axis, and the y-axis passes through 0 on the x-axis. So whenever you are finding x-intercept, make y 0, and then the y-intercept make x 0. So for the x-intercept, so for the x-intercept, y equal to 0. So we are going to have 7x plus, for wherever we see y, we put 0 there, plus 2 equals 0. So 7x is going to give us negative 2. And we divide through both sides by 7 to get x equal to negative 2 over 7. And that becomes our x-intercept. And for the y-intercept, x will be equal to 0. So let's do that quickly. All right, so our y-intercept also becomes negative 1 over 2. That is when x is 0. Then we take the second question quickly. The second question is x plus 2y equals 10. And because I spoke about equation b in this form, I'm going to turn it into this form to use. But you can still use this one to solve it. It doesn't matter. But I just want variety, so I'm going to do that. That means I have to go ahead and make y the subject. And we start by making 2y the subject to be negative x plus 10. Then I divide through both sides by 2 to give me negative 1 half x plus 5. So that means from what we have discussed, this is the gradient of our line. So you say that our m equals negative 1 half and our y-intercept is 5, which is here. It is a number, the value we get when we make x 0. And then you just go ahead and find our x-intercept. So we find our x-intercept by making y 0. So if we make y 0, we're going to have 0 to be equal to 1 half x plus 5. I move x to the left to give me 1 half x being equal to 5. Then multiplying both sides by 2, I'm going to get x to be equal to 10. And that becomes my x-intercept, meaning that when I make y 0 here, my x is going to be 10. So that is how to find the gradient and the x and y intercept of a straight line when you are not given 2 points on the line, but the equation of the line, and you have to find them. So now we are going here, the third side of it, any linear graph. And that one I don't hope to spend any much time on that. Let's take as an explanation of that quickly. Assuming we have our Cartesian plane, with this being our x-axis and y-axis, and we decide to draw any arbitrary line. To find the gradient of this line, it's just like the first formula we did. You find any 2 points on the line, say AB, and you trace these points to the x-axis and to the y-axis, to the x, to the y. So let me call here x1, x2, this is y1, and then y2. Let me just write the y1 to here. Then we just use the formula m equals y2 minus y1 all over x2 minus x1 to solve it. So I will not spend any much time on that. That is all you do when you are given the line already in the Cartesian plane and you are to find the gradient or slope of the line. You just locate any 2 points on the line, trace it to the respective axis, and then fix them into the gradient formula. That is what you do. So we go back to the last one, which is when giving the angle of the slope or the angle the line makes with the positive x-axis. So assuming we have our Cartesian plane, good. So assuming we have our Cartesian plane and then we have our line here. And the question tells you that the line makes an angle, let's say theta, with the positive x-axis. Then the gradient of this line here, m, will be tan of the angle the line makes with the positive axis. And in this case, that is going to give us tan theta, because the line makes the angle theta with the positive x-axis. We just take a quick example. First example is find the gradient of the line which makes an angle of 45 degrees with the positive x-axis. So with a question like this, we've explained everything already. So we just write our gradient m equals tan, and this time our theta is 45 degrees. And we just have to check that with our calculator. And tan 45 is 1. So we say therefore the gradient of the line is 1. Okay, so this is where I try to bring down the lesson on the gradients of straight lines. Just as a way of recap, we first of all started by saying that the gradient of a line is the measure of the steepness of the line. And we said that gradient of a line can be found using different methods or under different scenarios. And the first one, we said that we can find the gradient of a line when any 2 points of the line are given. Then we are going to use the formula change in y over change in x to find. And then we also said that we can find the gradient of a line when the equation of the straight line is given. And by that, we are saying that when the equation is given in the general form, which is ax plus by plus c equal to 0, then we can simply write the gradient as mb equal to negative a over b, which are the negative ratio of the coefficients of x and y. Or better still, we can make y the subject of our equation, and then we pick the coefficient of x as our gradient. And the constant term becomes, in the second case, a constant term becomes our y-intercept, which is the same as the value we get when x is 0, or where the line cuts the y-axis. And we said the x-intercept can also be obtained by just simply making y 0, because the x-intercept is where the graph cuts the x-axis, and on the x-axis y is 0. So we just fix 0 into it there. Then we are saying that we can also find the gradient from a linear graph, meaning that the line has been plotted in a Cartesian plane for us to find the gradient. We simply go ahead and then locate any 2 points on the line, and then we just go and use the formula when 2 points are given to find. And then the last thing we spoke about is when we are giving the angle between our line and the positive x-axis, we take tan of the angle, and that gives us the gradient. I hope this lesson has been of help to you. If yes, why not consider subscribing to this channel for more videos, so that you'll be notified anytime I have uploaded the video. Thank you for making time with me in my study room, and I hope to see you again. Bye bye.